number of categorical notions during a long time to arrive to have the notion to construct, to new categorical notion, to construct the notion, to construct the categorical model of MENS, which is a model with a frame, unit frame, in which we can develop both the neuronal, mental, and cognitive process. And this was developed on a long period of time since we began this work in the 80s. And at this time, I was a mathematician with my essentially in analysis, and then with application of category to analysis in my Paris PhD in 1960. And I had also then a number of publications with Andrée Ehresmann, which has been my late husband, and which on category theory, and in particular on the theory of sketches and on the multiform category. And we thought that category theory approach could open a web of opportunities to understanding of complex process of intelligence. Now, Jean-Paul Montgomery was a young physician in the 80s, and he was most interested in the problems about complexity, emergence, and cognition, which were well developed in France at that time. And he asked me if it would be possible to use category theory to develop this notion, and it was the beginning of our work, the beginning of the time we worked together. Now, when something, well, the talk will be divided in four parts. The first part will be about the hierarchical evolutive system, which model natural system with a complex, which are complex and hierarchical, and so such the biologic system and so on. And this part will be exactly the result and indicated in our first long publication published in 1987. And the second part was on the degeneracy of property, and we show how this property, which is at the base of complexity and emergence. The construction of the MENS, of the categorical model MENS for neuronal mental system, will be in the third party, and the fourth part will be how the higher part of the memory of MENS is at the source of the notion of consciousness and so on. So the first part what is the problem? The problem is that the complex systems, evolutionary systems, such as natural systems, have the following properties. There are evolutionary systems. They have a tangled hierarchy of components varying over time. The change of state consists in the standard structural change enunciated by terms such as birth, death, collision, confusion, and they are multi-agent dynamic. Now, if we want to model this in category theory, we have problems because we need notions which do not exist. And this is the reason for which we have to introduce this notion before going further. And these notions are evolutive systems, and then hierarchical categories and the complexification process. So I will begin by defining these notions, which are essential for the following. So, evolutive system well, the evolutive systems are will model the dynamic. Now, the dynamic of the system. So we first have the interval of time, which will be the time during which the system will exist, and for each t on this interval t, we have a category T, which represents the state of the system at this time with its components, and so the components are the object at that time, components which exist at that time, and the morphisms are the relation between these components, these objects at this time. Now, from T to T prime, we have a functor, but the functor is not defined on all the category KT, but only on a part of this category. Because it's the reason we have said that there are separations of elements between at each time. For example, if we think the categories represent categories of neurons, you have neurons which die at each time. So the functor is only a partial functor from Kt to the category Kt prime. And in this way, we have a functor. The evolutive system is defined as the functor from the category defining the order on the times to the category of partial functor between categories. So you see, the evolutive system is something slightly different from a shift of categories because we have at each time only a partial functor between two different times. And the component of the system we are described here. We have here, for instance, a component, small components, here a larger one. The component is the maximal family of objects of the category related by the transition functor. And we see here, for instance, this component stops at the T prime because here the line indicates what is will be lost, suppressed at the next step. And the components can be seen as the component on each segment I where there exists can be seen as defining a shift of over the topology of now the example will be essential for all the rest of the work because it is the evolutive systems of neurons. At each time t, we have the graph of neurons, which has the neuron with their fighting for line as the objects, and the arrows are synapses between the different neurons. And with the propagation delay and also their strength around. But this graph is effectively a graph, but not a category. And we need a category in an evolutive. So we define the category of neuron T as the category of parts of the graph which I have plotted. And so in the evolutive system of neurons, it's this category which will be taken at each T. And the transition curve will be just the fact that the transition functor stands the state of the neuron at T on its state at I, if the neuron still exists at T prime. Otherwise, the functor is not defined on this neuron. So we have this. We have called it. Now we need to define the notion of the hierarchical category. The notion of the hierarchical category is following what? We suppose we have the distribution of the object of the category in different complexity levels. From 0 to 1, there are designed here. This is level 0, level 1, level 2, and level 3. And what is the property? The category must solve is the fact that if we have an object at the level n plus 1, there exists at least one diagram taking its values to the category, taking its values in the lower levels, so level strictly less than n plus 1, if the state is at level n plus 1, and so that, and this way we have the fact that C will have also ramification down to the lower level. If we take C, it is the polymic of P, then for each Pi here, it has also the polymic of another pattern at lower level, and so on, down to level 0. And we define the complexity order of an object C as the smallest length of one of its ramifications down to level 0. Because the same object may have a different ramification, not only one. And so this is the complexity level is defined by analogy with the Kolmogorov-Chaitin complexity level for complexity for a string. And we see that, and we'll show later formally why that category we have a pure reductionism, meaning that C is directly can be a ramification of level 0 and 1, that is pure reductionist. And we'll see that the condition for that is that it had only one ramification. So this is the hierarchical category. Then the complexification process, which is to model the standard structural changes. How can we, if we have a categories, how can we, for instance, here, HT, you probably don't see the other part of the drawing. How can we modify this category to surpass eventually part of it, or to add a polyimide to a pattern which has no polyimide? And the complexification process is to find a universal solution to this problem, leading to the relative completion theorems of the category, which have been developed by, which we have developed by Charles and myself in 70. So, but here, the example given here to just suppress subgraph S here and to add a cone, one polyimide, naturally seems very simple, but when you have many polyimides to add and so on, it begins to become very complicated, but we are given an explicit construction of the complexification, which sometimes necessitates transfinite reasoning. So we have this corresponds to the results we had obtained up to 98. And then there was a correction of the book of the Gerald Ehresmann, the Remember Test. And this book was most important for us because it just indicates what will be the basis of the problem of complexity emergence by applying, defining in a category the analog of the degeneracy principle of the neural code which introduced them. And the degeneracy property by Ehresmann is that more than one combination of neuronal groups can yield a particular output, and a given single group can participate in more than one kind of signaling function. So why is it so important? Because it will indicate the difficulty. The notion is, it will allow in a category to define the notion of multifaceted objects. So for that, we consider we have to define the notion of the cluster, but I don't have the drawing which explains what it is. It's a kind of morphism in a category. If we have two diagrams to this category, we can define a kind of morphism between these diagrams, which are not the morphism generally defined in the category of diagrams, but which are the clusters. And a cluster is data of a number. I will not be given the exact definition, which is not necessary here, but what is important is that if we are just a cluster from Q to P, then and if P and Q are polymeric, then there is a binding link which resume, which collect, which binds all the links in the cluster. And the cluster between small diagrams from the category which is isomorphic to the co-completion by the diagram of the category. This category has been well studied by in terms of clusters, and the notion of cluster have been well defined by R1 Verrier in his 2020 sheet. And now the degeneracy property means that which is a kind of flexible redundance, means that there exists no that there can exist two diagrams in the category which are the same polymorph, but and we are not isomorphic nor related by the cluster with expanding the identity. But we are and this condition, we are the third to enunciate and the way in the other way, upside down, and to call it the multiplicity principle. So the multiplicity principle will be the main principle which we will have to consider, because all our work is important, use it is important. So the multiplicity principle said in this way, saying that do two diagrams in category K satisfy the multiplicity principle if they are the same polymorph or only virtual polymorph, but I will not enter now into this problem. So let us say have the same limit, but there is no cluster between P and Q whose binding is the identity of the object. And in this way, the object is called a multifaceted object. And if the category is hierarchical, it will be called n multifaceted if it is a polymorph of different diagrams of level less than n. So this will be important because it leads to the existence of new morphism, which we call multi-part link, as it is denoted on this figure. You see, if we are in a category where the multiplicity principle exists, and so that C will be the polymorph both of this pattern P and Q, and so there is no cluster which binds to the identity between these two patterns. Here we have what we call the switch. And if here we have a cluster and this binding thing here, the same on this side, we see that the composite, there must be a composite of this binding link and this binding link. And but if we are just in a hierarchical category here, we have nothing. If we are at the level K0 here, we have no possibility at all to to know that there is a link here, since just by the knowledge that we have at this level. Just say knowing that the two categories have the same limit, and that there are because the link here has nothing to do with the links from this pattern, this diagram, and to this diagram. So it's really the real emergence of this link at the level K plus 1. And so, in fact, here we have another example of the complexification process. If we just look at this part of the category under those two levels less than n plus 1, with the level n plus 1, the category will be the complexification of this category. For instance, by adding this and this cone and this cone. So we see that the multiparts have also another kind of complexity which intervenes. And now, if we take a hierarchical evolutive system, is an evolutive system, but in which all the categories are hierarchical. And we say that it satisfies the multiplicity principle if there are so the MP, if at this level n there are multifaceted objects of level n, and multifaceted objects of level n. And now we have the two main theorems so important of the multiplicity principle. The complexity theorem, which says that MP is a necessary condition to show that there exist objects in the hierarchical evolutive system of so that there exist objects of level well, I have not correct. The multiplicity principle is necessary condition for the existence of objects of complexity order which is more than 1. Because otherwise, but it's complicated to prove what I said earlier, that it's complicated. This theorem is complicated to show complexity theorem. And so this explains if we have multiplicity principle, the system can be complex. You can have it's not pure reductionism, but we can think of an emergentist reductionism in the sense of Mario. And the other important theorem is the emergence theorem, which says that in US, which satisfies the multiplicity principle, a complexification process can lead to the emergence of objects of higher and higher order complexity order. And so this explains exactly and with multi-and also with multi-part. So we have the emergentist reductionism well understood. And by corollary, in such a system satisfying multi-principle, there can be development of the memory formed by successive complexification, formation of the memory with objects which have more and more high complexity So we see that we are effectively, multiplicity principle is really what shows that we have complexity and emergence in the system. Now we want to construct MENS. So the model MENS we have taken is a categorical model to study both the neuronal and mental system. So the first way, how can we represent mental objects? And the idea is that MENS will be obtained by successive complexification of the neural system. So it will be the hierarchical evolutive system with the subsystem of level 0 is the hierarchical evolutive system of neurons, not the evolutive system of neurons. And its higher level will be the element we call category neurons, abbreviated in CAT neurons, will be obtained through successive complexification of the lower level. And this MENS will have higher order memory, consisting of records of higher order, which are, and this archetypal form will be at the basis of the formation of higher cognitive processes and consciousness, as we'll see in next time. Now, how can we define the mental object? It is known that have, as this explained, that a stimulus generally, which is repeated, allows to activate synchronous assembly of neurons, and that this assembly becomes more and more complicated, more and more stable if the stimulus is often repeated. And there's even the head rule for the strengthening of the links in this assembly. And synchronous assemblies of neurons play also an important part in the book of Changeux on the log neuronal, which appears in 8th. And he says that l'objet mental est essentiellement l'objet mental est identifié à l'état physique, alors il le décrit, l'entrée en activité d'une large population ou assemblée de neurones. How will we be able to model with all what we have also talked to now, the mental? Well, the idea is that the assembly of neurons will be represented by the synchronous assembly of neurons will be represented by a diagram P in the category of neurons at the instance T. And this assembly generally will not have a colimit in the category of neurons. Why? Because this category is constructed as a pre-category. It is a category of part of the neuron. So, in fact, and I have told that there are not many colimits in such category. And in fact, it was known that there were only, if there are co-limits in the category of neuron, it is generally an element of the assembly itself. As has been shown, for instance, by Amari Langlois. So what will be, so if there is a limit in the neuron, this will be considered that when it is activated, it will be mental object. It will be the mental object associated to. But if it is not, then we made a complexification of the category of neuron, to which we add a co-limit to the assembly P. So it's what we had here. We are in nerve, and we had the CP, and we call it cat neuron of level 1. And the process can be done anew, and in this way we can define whole algebra of mental objects of increasing levels and terms of change, and with no difficulty. So now let us take the higher levels, cat neuron. So we are at the government we have MENS. Of MENS. We have first the level 0 nerve, and above we have the different cat neurons, which have, each one has been constructed by a complexification, adding a co-limit to an assembly of neurons without a co-limit in them. But so this is the first part of the first level of the MENS, and it is obtained also. You can say that it is just the complexification of nerve. We add such that neuron of level 1, and by deduction we can go on and do that to define that neuron of increasing level. Here, for instance, that neuron of level. And what is important is the activation of that neuron, since it will be exactly the mental object will be represented as say by change by the activation of the cat neuron. And how can we activate the cat neuron? So if we have the cat neuron here M, we know, since we have constructed by induction more and more complexification, and this M is as ramification does to the neural level. And these different assemblies of neurons of level 0, these different diagrams of level 0, which are the synchronous assemblies, are called the base of the ramification. And so we are, and if the base is activated, the activation will go along the links of the ramification up to F. So that we can call this big base of the ramification the physical neuronal realizability of the cat neuron F. And the physical realizability was given the name by Tim. And so, but as a cat neuron can be multifaceted, this realizability, physical realizability, may be realized there might be two completely different realizability of that neuron, and both the fact that there are both in this way means that there are several physical realizability of the mental object. So no univocity between mental and physical object, and with things MENS, where I have shown that this means that we can define what Varela was searching at now, saying the physical neurophenomenology, which Varela could not define because the idea was that there was unicity of the realizability, physical realizability. Now, the activation of the PET neuron here stems from the activation of the base of one of its ramifications, and so it has some delay of propagation, because the delay of propagation can be extended in case of competition, and so we have when the activation comes, the delay of propagation is the maximum delay propagations of the different links to M along this ramification, and it means that when M arrives, when that is activated, in fact, it is activated long after the activation at the neuronal level, which explains that the information which arrives and which is important in the case of consciousness, the activation will arrive later, so concerns over. Now, MENS is also a multi-agent system, and there will be a problem. In fact, meaning that there are a number of agents which are called co-regulators, which each one with its own function, and which are generally based on the part of different parts of neurons, particular part of important neuronal nodules, and each co-regulator access only to some small part of the information which come by the links which arrive to him, and comes in this way. This landscape here is formed as for component, for object, the component here. The different co-regulators work separately, each at one temporality, and they select procedures to make comments to this procedure and activate their effectors, and that there can be problems between all these comments can be not well compatible, and this leads to factors for some co-regulators. But I will not insist on this part, because I see that the hour is completely past. So now I am in the part 4, on the archetypal 4, at the base of consciousness. Should I continue my talk or to stop at here?
It's like, I think because we started 10 minutes late. Can you hear me now, Andrew? Because we started 10 minutes late, you can continue for 5 more minutes or something, if that's helpful.
So, about 10 minutes, I could just show the base, the slides.
Vous pouvez continuer pendant 5 minutes, comme on a commencé en retard. Je ne sais pas si vous m'entendez. Vous pouvez continuer pendant 5 bonnes minutes, puisqu'on a commencé avec 10 minutes de retard. Ça laissera un peu de place pour les questions après. D'accord?
Oui, ben ça me permettra de faire comprendre l'idée. Ça ne permettra pas d'aller loin, mais comprendre l'idée.
Good, merci.
Donc je vais essayer. Voilà. Alors, d'abord, nous avons utilisé un résultat qui est purement neuroscientiste. Neuroscientist result is that the structural there is the structural core in the man cortex, which which has been discovered by Ehresmann and others, and which this core may be an important structural large-scale brain for brain dynamics. So here it is destined. So it is. Well, so this structural core will use it to define the archetypal core. What is the archetypal core? We have said that in the hierarchical evolutive system, and we have said that MENS is one, there is the memory which develops, and the memory has more and more complex system, which can be more and more complex record, and record not only higher levels, but also higher complexity of. And the archetypal core is the part of the memory, the higher part of the memory, and it consists of and it is to conclude, we consider that it is the memory, that it is a complexification of the structural core. So the authors in the archetypal core are ramification going down to the structural core. And this records are many multifaceted, and that they act quickly, and for a long time they are often repeated. The archetypal core in some way represent the idea, the memories of the self with. And as this, for instance, the sun will be seen with many modalities, but also with many ramifications and so on. So in the archetypal core, by Hebrew rule, we have strong links between the object of the archetypal core, which form archetypal loops, which entertain their activity for a long time. So the archetypal core, we see that it has many, is strongly activated, and this activation can go down through unfolding of the ramifications, and then go back to some co-regulators, which are called intentional co-regulators, who are based on conscious units of script, and this so we have in this way there is formed a large macro landscape with these different co-regulators, which are something which come by there and also by directly linked to the acid. Now the problem is that here there are animation which are not, I try to see if I can. Yes. So we see that when we have an activation to one of the archetypal objects, which can be come from somewhere in the structural form, since we have said that the archetypal is based on the structural form, then the activation will go down first around inside archetypal loop, then it comes back to the through ramification and comes back later to the intentional CRs which are linked to the archetypal form, and so we have a formation of the macro landscape, the macro landscape, which unite and made and increases both temporally and spatially the landscape of the different co-regulators. And here, this ML has a longer timeline for the landscape, and in it there are intertwining processes which can be done, propagation of the activation for loops in the assay, then the ramification, unfolding of ramification, sharing of sharing of activation between the co-regulators, the intentional co-regulator, and record. And through these links which come from lower level, we have said that they transmit an anterior information in this way. So we have in the macro landscape, we can have we will have the process, the consciousness process can be defined in this way. When we have activation of parts of a state, for instance, because there has been a stimulus or something which has a striking event of any kind which in the structural form, this goes up through the ramification to activate some archetypal objects. Then this activation propagates along the archetypal form, then and allows to form a macro landscape. And in this macro landscape, we can define two related to time, notions, both the retrospection process, which analyzes situation and recall to make sense of S by abduction. And it is, we have here in the macro scale, and here we go to lower here, since the holding of ramification, and so something which has been done earlier than what is here. And we have also a prospection, which in the macro landscape we can develop scenarios for constructing virtual mental spaces in which we can try to make different process to see what the complexification of them would be. So we see in this way the phenomenal consciousness would be essentially this two conjoint notions of retrospection and prospection. And these
yeah, sorry, Andrée, can you hear me? Yeah, I think you'll be going into, if you want to have one question or a couple of questions from the audience.
It is the end. This is the last area. And yes, we see that we are the retrospection and the prospection can be compared with what Husserl called the retention and the potential, and the macro landscape can be compared with the global workspace of Marx. So this table resumes the link between brain, MENS, and mind, and the fact that we see that the important thing are that the multiplicity principle allows to have complexity and emergence, and the formation of man allows to have both neural, mental, at the same way, and to define also the higher cognitive processes and the consciousness, and here we present essentially consciousness as the possibility of retrospection in integration of the time dimension, both toward the past and toward the future. And so this is.
Okay, thank you. So we might only have time for about one question, I think, unfortunately. Toby, yeah? You might want to come up here to ask it, maybe. We're just going to have somebody, Toby, come up to ask a question.
It's right there where the camera is.
Okay.
Est-ce que vous m'entendez?
No? No.
Vous m'entendez, Andrea?
Oui.
Okay. So it seems like cell assemblies and cat neurons are very important in neuroscience. Do you know or do you have a proof, say, that the head rule, say, generates cat neurons as in your framework, or is this more of an analogy?
I don't understand the question.
Est-ce que vous connaissez que le rule head génère les cat neurones comme votre formulation?
Oui. I think.
C'est un théorème?
Yes.
Ah, super. Merci.
Yes, everything is has been proved in some or another of our publications. I have only given proofs when I had a real proof, mathematical proof of the thing.
Donc c'est pas juste une analogie.
No. It's effectively based both on what is known, perhaps, well, you should know that this work has been done essentially. The last article on this was written in 2019, so that we have not, perhaps there are more recent results which we don't know, but at that time we have tried to be correct and to only give results when we had real proofs.
Ok, génial, merci.
Okay.